Quadratic functions are second degree functions. I guess we could call them, for short, x squared functions. And we're just going to kind of work our way up degree-wise. You know, we talked about linear functions, which were first degree functions, lines. So yeah, we're just working our way up. And we're going to consider second degree or x squared equations. Equations that have some way or another x squared, and that's the largest power that x has, is the second power. Now, the good news is we do know already what these look like. We talked about these a little bit, right? F of x equals x squared. We talked about that. That was one of our common functions. And so yeah, we know a little bit about what these look like. And I think I mentioned back then that these were called parabolas. We're just going to talk a whole lot more about them today. So f of x equals x squared. The basic shape is this. Now, we'll consider two basic types of parabolas, because we've got this type, and then we've also got the minus x squared. And the difference on it is that it's down, right? It's flipped over. We said it was reflected in the x-axis. But those are the two types of parabolas that we'll consider here or talk about. So this would be a parabola that opens up, we'll say. Okay, it's a parabola opening up, and this will be the parabola that opens down. And we already know a little bit about why the two are different, because, well, what's different about them? What's different about these two equations, if you will? What makes this one open up? What makes this one open down, you think?
A negative.
Yeah, it's the presence of that negative in front of the x squared. Now, we'll consider that number in front of the x squared. That'll be our a. It's very much like in the quadratic formula, ax squared plus bx equals c. That's going to be our a. So opening up or down is going to depend on that number in front of the x squared. The a, we'll call it typical. We'll talk more about it, but yeah, if the x squared is positive, it opens up. If the x squared is negative, it opens down. That's our basics here. Now let me draw another one, because of course what will happen is we'll do much more complicated ones than these, of course, right? And so what will happen is, we'll have parabolas, but they'll be shifted and different things will happen to them. So let me just draw one kind of in general and talk about it. So let's say this one's shifted kind of up here in the first quadrant. It doesn't really matter. I'm just going to talk about our little parabola here. Some other parts, of course, this one's opening up, but same thing would hold for one that opens down. First of all, one thing we consider, like I said, this one's shifted over a few units up and to the right, but that point there, that low point in this, and of course over here, it'd be 0, 0, that particular point. That point is called the vertex. The low point or the high point, that point is called the vertex of the parabola. And so this one's shifted over, like I said, into the first quadrant. And it's a point. The vertex is a point, and so they give it a name in general. They call it h comma k. And so h comma k, that will be the designation for our vertex. All right. And so there's one other point to make here. If I drew a line right through the middle here, vertical line right through the middle. I didn't do a real good job of producing or drawing this parabola because that line right there represents what's called the axis of symmetry. And what that means is it's the same on one side as the other. In other words, a mirror image, that graph is a mirror image. If you draw that line right through the middle, it's a mirror image. In other words, this point mirrors this point. Let me draw it a little better. This point would mirror this point. They're the same distance away, in other words. At that same height, those points are the same distance away. And so that's why it's called the axis of symmetry. It's symmetrical about that. And that can help us draw these, some of these parabolas, as we'll use that fact in a little bit here. Okay? All right. So those are the basics. You've got an opening up or down, and you've got a vertex and that axis of symmetry. That's the parts of a parabola that I'd like you to know right now anyway. All right. Now, like I said, the good news is we've kind of already talked about these x squared graphs. We've shifted them around. And we're just going to talk a little more about them and label some different parts, I guess you might say, here. But that's where we're going to start, is with our using our shift, what we know about shifting and reflecting and some other things. I like to think of these in two forms. There's two forms that we're going to talk about for quadratic functions, and this is form one. I call it vertex form. The book may call it standard form. Other places call it standard form. But I like the terminology vertex form, and you'll see why in just a second. And here's what, let me just give you one. F of x equals 2x, 2 parentheses, times x minus 1 squared minus 3. All right, this is an example of a quadratic function in vertex form. I like to call it vertex form, standard form, other places call it. Yeah, now, we know a lot already about this, don't we? Because the way we approached it, we didn't really call it any certain type of form, but we recognize it's the x squared graph that's been shifted, transformed several different ways. And so let's just look at that and let's talk about that. How has this one been shifted? How will this graph be shifted?
Right one.
The 1 is in the parentheses, so that makes it go right or left, and then minus. Now there goes to the right. And then what about the minus 3?
Down 3.
That's down 3. Okay, so I've got right 1 and down 3. And we didn't talk about it a whole lot, but we did a little bit. Remember the 2 in the front, that doesn't shift it right, left, or up or down or anything like that. Remember what that does? That stretched it. That made it stretch. And for parabolas, if you stretch it by a factor of 2, that's going to make it narrower. So this is going to be a narrower graph. However, the one thing that we can talk about with that 2 also here is that's going to be if you multiply this out, all right, what that 2 will be is, it'll be what's times x squared, right? Because if I fold that out and then multiply by 2, that's going to come out to be 2x squared, whatever else the other stuff is. The first part of this is 2x squared. And so I say that because doesn't this tell me whether that opens up or down? Because it's going to be a positive 2x squared. And so the positive x squared one, that's going to be opening up. So like I said, that's going to be what we call A, and so A being positive or greater than 0, that means it's going to open up. And so, right off the bat there, we can tell a lot about this particular function, that it, just by using those bits of information we kind of already know. All right, so, and we'll do, all right, so let's do it this way. Here's kind of how we'll graph this for now, and then we'll talk about the results here. All right, so we're going to take, this takes the x squared graph, right 1 and then down 3. So here's x squared. And so if I go right 1 and then down 3, particularly, that's going to put my vertex where? Well, down 1, I mean right 1 and down 3, right? So my vertex here is, it's 1, -3, right? That's going to be my vertex. It's going to open up, so it still has this same shape, but it's narrower. Like we said, the 2 factor makes it stretch by a factor of 2, and so it makes it narrower. Here's x squared, so it's going to be narrower than that. Now, what I like to do on these, this particular vertex form is look at the y-intercept, because since we already have the vertex, let's get the y-intercept, because that's usually not too terribly difficult to a point to get, because how do we get the y-intercept?
X to 0.
X is 0, right. So that's usually pretty easy one to get. So it'd be 2 times 0 minus 1 squared minus 3. So that's going to give me a y-intercept of, well, it'd be 2 times -1 squared. But it is -1 squared, so that's +1, right? -1. 2 minus 3. -1. Y-intercept. Leave that. Okay, so I've got my vertex. Now I've got my y-intercept here. If you think about this axis of symmetry also, that's going to give me another point, because by the axis of symmetry, isn't there a point this same distance away from this axis? So if this is the vertex, my axis of symmetry, the axis of symmetry runs right through the vertex. Okay? And so I've got this axis of symmetry running through here. So there's another point, yeah, there's another point on the other side here at, that'd be a +2, but at -1.
Can you say that again?
So by symmetry there, since I've got this point here, there's another point on the other side of the axis of symmetry, which the axis of symmetry just runs right through the vertex. There's another point, same distance away at that same level. So since I know it's a parabola, there you go. So that more or less how we're going to do this. But there's our parabola. Okay? Now, here's another nice point about this. Do you notice here, these numbers are kind of related to some numbers up in the equation? Where did this 1 come from? And that -3, those aren't by coincidence. Those are the same, and it's not by coincidence. Because of the shifting, right?
It's got a relationship.
There's a definite correlation there, yes. So that's why I like to call this vertex form, because I've got the vertex sitting right there in the equation, right? So here's the general form of this vertex form. So vertex form looks like this. F of x equals, like I said, we're going to call this number in the front here A. In this case it was 2. You'll see, we'll see that number pop up several times. All right, then we're going to have an x minus, and then this number was h, right? We called the vertex hk. So this number right here is h. And then this was the y value of the vertex, so that's the k. Plus k. Now, pay attention to my signs there. It's x minus h plus k. So this is a vertex form of parabola with vertex h comma k. Now, like I said, pay attention to what I wrote there. This is minus h, but the vertex is h. So those are opposite, right?
Is it because it's squared?
No, it's because of the shifting. A minus one goes to the right, and a positive one would go to the left. And so you're going to do the opposite sign here for your h.
And I'm sorry,
And then the k is just straight up.
so the A is the first one, which would have been the 2x squared,
The 2,
the
yeah.
first. And then the H
H
is
was,
the negative one.
it's minus 1 here. Notice the
Yeah.
Yep.
H was positive 1.
Okay, and then the K is the Y.
And then the k is minus 3, just like this. And we'll do a couple more.
Okay.
So. All right. Now, what about the A? Well, if A is greater than 0, meaning positive, greater than 0 means positive. So if A is greater than 0, then the parabola opens up. If A is less than 0, because that would mean it's a negative x squared. So if A is less than 0, negative, then it opens down. Okay? So that's vertex form. It's a nice, neat little form. Okay, so let's go all the way through one, now that we know all this stuff. Maybe do a couple of them, and then we'll talk about the other form. Okay, any other question? Good on that? All right, so f of x equals negative 1/2 x plus 3 squared plus 5. All right, so what can you tell me about this? It's a parabola because we got x squared
Gonna be opening down,
and it opens down. Why is that?
negative.
We got a negative 1/2 in front there. Yeah, a is negative 1/2, so that, since the a is negative, it opens down. All right, what's my vertex?
Negative 3, 5.
Negative 3, positive 5. Why is it negative 3?
Because it's opposite.
Yeah, you do the opposite there. That's right. For the h, you do the opposite of what's inside with the x. So you got a plus 3 here, so it's negative 3, and that's again because of the shifting. That's going to make it go 3 to the left. This is straight up like it is, positive 5. So everybody okay? Why we did that? Okay? Yeah. So we pretty much got this graph hammered out here. So the vertex is negative 3, positive 5, right here. That's my vertex. It opens down, and so the vertex is going to be the high point because it opens down. Like I said, to get the other thing I'll have you do on graph-wise here is the Y-intercept. Because it's not too bad to get, usually. Negative 1/2. Make x 0. So we got negative 1/2, 9. Negative 1/2 times 9. What does that make it? That'd be negative 4.5, so it'd be plus 5, 0.5
0.5.
or half, yeah. So the y-intercept's 0.5. So it's going to cross the y-axis at 0.5. And again, we've got that axis of symmetry running right down the middle. And so that point, then there's another point over here. What would it be at 3? That one's 3 here, so it'd be 3 over here and a half. With me there? We get a pretty good idea of how that parabola is shaped. Yes?
So with the Y-intercept, you just shifted it up the half point and got
Yeah.
it right there. And
Y-intercept's a half.
then- And then you just,
Then there's another one at a half, the same
The other
distance
side.
away over there. Symmetry. Any others? Good on that? All right. So So those are fairly quick ones. Let's do another one. See how we do here. All right, number 2. Let's call it f of x equals a negative 2 times parentheses x minus 3 squared plus 11. So again, this one's a parabola. Now if that's not squared, this isn't a parabola, right? It's got to be x minus 3 squared. It's got to be x squared to be a parabola, but these all will be, but just FYI there. Opens again, in this case, down.
Down.
2 is negative. Now this one, we didn't mention it, but the 1/2, what it did is made it wider than the x squared normally is. This one's going to be again narrower because it's a negative 2, but it does open down again. And what's my vertex?
3,
11.
Positive 3, positive 11, yeah. We do the opposite of the one that's inside from the with the x in the parentheses. Do the opposite, but then the k is just whatever it is, positive or negative, just take it as it is. Okay? Positive 3, positive 11. Positive 3, positive 11. That's my vertex. And since it opens down, here we go. All right, to kind of get the width or whatever right, let's do an intercept, the y-intercept. So that would be y equals negative 2 times 0 minus 3 squared plus 11. Well, that's going to be negative 2 again times 9 plus 11. Negative 3, but it's squared, so it'll be positive 9. That's going to be negative 18 plus 11, negative 7. Y-intercept is negative 7, so it's way down here.
I messed up with the negative there.
Negative 7, that was right.
It's
Looks
correct,
okay.
I just got positive 7, so
Oh,
I
okay.
forgot to drop my
Okay.
carry.
All right, so yeah, again, you got that axis of symmetry. And so you got another point at negative 7 on the other side. Be at 6, yeah. So yeah, that gives you, and if you want to, put some other points in there too. Make sure you got it, but yeah. Fairly easy graphs to do if it's in that form. Any other question on that one?